Have you ever reached into your pocket, pulled out a handful of loose change, and just wondered, how on earth do these things survive? I mean, they get dropped, scraped, and passed around for years. Or what about looking up at a massive commercial airplane soaring overhead and thinking, what kind of material can possibly withstand the sheer stress of flying? Well, the answer might actually surprise you, because the everyday objects we rely on, literally from the change in your pocket to the wings in the sky, they all rely on a hidden science. It turns out, nature's pure elements, yeah, they're rarely up to the job on their own. Welcome to our explainer on the secret strength of metal mixtures, where we're going to unpack exactly how mixing materials completely transforms our world.
Here is our roadmap for today. We'll be covering 1. The pure metal problem. 2. Inside an alloy's atoms. 3. Alloys in everyday life. 4. Comparing brass and bronze. And finally, 5. Smart metals and medical marvels.
Okay, let's dive into Section 1, the pure metal problem. We tend to think of the word pure as this ultimate standard of quality, right? Like pure gold, pure silver, pure iron. But here's the catch. In reality, pure metals are incredibly soft. If we built our world with them, they'd just dent and bend under the pressure of daily life. So to solve this massive problem, we create what's called an alloy. Now notice the key detail here. When different metals are melted together, their atoms mix, but they do not chemically bond. They just physically mix together, and that creates an entirely new, hardened material. It's a real game changer.
And you know what? Humans actually figured this out thousands of years ago. Just look at the incredible detail on this 4,000-year-old bronze head from Iraq, or the Greek statue right beside it. Ancient peoples realized that by taking soft copper and melting it down with tin, they created bronze. And this resulting alloy was significantly harder and way more useful than either of its soft base parts.
Moving on to Section 2. Inside an alloy's atoms. Let's zoom way in to see how this works.
This brilliantly illustrates the difference. Look at the left side, showing a pure metal. See how the atoms are all the exact same size, arranged in these perfect regular rows? Because of this uniform grid, when you apply force, like hitting it with a hammer, the layers of atoms just slide right over one another super easily. That's exactly why pure metals are so soft and malleable. But look over on the right. When we create an alloy, we introduce an atom of a totally different metal, which naturally has a different size. This differently sized atom completely disrupts that neat, regular pattern. Suddenly, the layers can't slide past each other anymore. They literally get stuck in place. That atomic disruption is the secret sauce. It's exactly what makes the alloy so much harder and stronger than the original pure metal.
If you want to visualize this disruption yourself, scientists use this really cool, simple experiment called a bubble raft. You just fill a dish with some soapy water to create regular rows of small, equal-sized bubbles. That represents our pure metal atoms. Then you take a syringe and inject one larger bubble right into the middle. The very second that differently sized bubble enters the raft, bam! The regular pattern of the surrounding bubbles is instantly broken and distorted. The grid completely loses its smooth, sliding ability. It is a brilliant, totally visible model of how an alloy gets stuck and hardens up at the atomic level.
Now for Section 3, alloys in everyday life.
Let's jump back to those coins clinking around in your pocket. Historically, we kind of romanticized the idea of coins being made of pure silver. But pure silver would actually be a complete disaster for modern currency. It is way too soft to survive being tossed into a cash register or a vending machine over and over again. Not to mention, it'd be crazy expensive. So the shiny, silver-looking coins we use today, they're actually hard-wearing, highly engineered alloys. They contain a specific mix of copper, zinc, tin, and nickel. That recipe gives them the durability to be stamped with complex patterns and survive in your pocket for decades. Now consider the number 24. If you've ever shopped for jewelry, you've definitely heard of 24-karat gold. That means 24 out of 24 parts are pure gold. But as we've just learned, pure metals are terribly soft. If you wore a 24-karat wedding ring every single day, it would literally squish and warp just from you gripping the steering wheel of your car or carrying heavy groceries.
To fix that squishy metal problem, jewelers rely on, you guessed it, alloys. Take an 18-karat gold wedding ring, for example. It mixes 18 parts of pure gold with 6 parts of stronger, differently sized metals like copper, silver, or zinc. By introducing those disruptive atoms we talked about earlier, the gold keeps its beautiful, shiny appearance, but it gains the crucial durability it needs to withstand a lifetime of daily wear and tear.
We even rely on this invisible atomic science when we fly. An airplane absolutely has to be built from a metal that is both incredibly light and remarkably strong. Now,
Aluminum is wonderfully light, but pure aluminum simply isn't strong enough. If an airplane's wings were made of pure aluminum, they would literally snap right off from the immense stress of flight. So engineers add magnesium and copper into the mix to create an alloy called duralumin. This specific mixture yields a material that is about 5 times stronger than pure aluminum, making safe, modern aviation entirely possible.
Moving right along to Section 4, comparing brass and bronze.
Brass and bronze are both incredibly important materials historically, and they actually start with the exact same foundation, a base of soft reddish-brown pure copper. But here's where it gets really interesting. The secondary element changes everything. For brass, we mix the copper with zinc. For bronze, like we saw with those ancient artifacts earlier, we mix the copper with tin. Let's look at exactly how those slight recipe changes yield wildly different results.
Notice how these tiny atomic tweaks change the whole shebang. With brass, mixing copper and zinc yields this beautiful golden yellow alloy that is highly resistant to corrosion. That makes it absolutely perfect for things like musical instruments and plumbing. But swap out that zinc for tin to make bronze, and the mixture becomes harder, a bit more brittle, and, crucially, incredibly resistant to seawater. That makes bronze the ideal material for casting heavy bells, sculpting, and manufacturing heavy-duty underwater ship fittings. It's the exact same copper base, but the specific atomic disruption from either zinc or tin dictates entirely different uses out in the real world.
Finally, Section 5, smart metals and medical marvels.
Custom alloys aren't just for building machines, they are actively solving incredible medical challenges today. You know, the joints in our bodies take an immense amount of wear and tear, and sometimes they're attacked by crippling diseases like arthritis. To give patients their mobility back, doctors now fit people with artificial replacement joints. But obviously, you can't just put any random metal inside the human body. These modern medical marvels are often made from specially engineered titanium alloys. They are lightweight, completely safe for the human body, and unbelievably tough, capable of functioning seamlessly for decades.
And engineers are pushing things even further, developing what we call smart metals. For example, there's a shape memory alloy called nitinol. It's a highly specific mix of nickel and titanium, and it has an almost magical property. If you take glasses frames made of nitinol and just completely mangle them, bend them totally out of shape, they don't break. But even more amazingly, if you simply heat that alloy up, it literally remembers its original structure and springs right back into its proper shape. How cool is that?
From ancient statues to jet airplanes to titanium hips, the story of human progress is quite literally the story of mixing metals together. So knowing that the secret strength behind our coins, our sky-high travel, and our medical breakthroughs all comes down to perfectly mixing and disrupting atoms, it leaves us with one really thrilling question to end on. What incredible, unseen materials do you think we're going to mix up and invent next? Thanks so much for joining us for this explainer, and remember to keep looking closely at the hidden science of the materials that make up your everyday world.